All right. Hello, everyone. Welcome to day 3 of Trigonometry. All right, so this unit is a little bit tricky, okay, and today's lesson is going to be very important, especially for those of you planning on to move on to pre-calculus and calculus. This is a topic that this is kind of a newer topic that can be uncomfortable for students sometimes to learn, and it's going to be very important, though, for those classes. You're going to use them, okay? You'll get more practice in them, too, but it's going to be super important to, the better you can understand this now, the better you'll be prepared for those future classes. Anyway, so let's get into things. So in geometry, we learned that sine, cosine, and tangent, yeah, it's kind of weird to look at those words in their unabbreviated forms. We learned that sine, cosine, and tangent are functions that relate the ratios of sides in a right triangle, okay, with an angle. Normally that angle is theta, right? Normally theta is what we talk about there. T-H-E-T-A, Greek letter, that just, makes the T-H sound, the th sound if you ever see it. Okay, so looking at, our model triangle over here, we're going to just, evaluate some of these trig ratios. So first we want to find the sine of this angle theta. So in other words, the angle for sine, this is like the input. And then the output, what happens with your sine function here, the output is you get an answer of a fraction or a ratio normally of two sides of that triangle, okay? If we use specifically the sine function, a sine applied to an angle will always equal the opposite leg's length divided by the hypotenuse length. So if you look over here, here's our angle theta, okay, right here. It's also angle A, it's the same angle there. So what's the opposite leg to angle theta? Well, opposite is side A, or leg A there, right? Whoops. And then the hypotenuse, it's always opposite the right angle, so that's going to be C. So it's going to be over C like that. Okay? Cosine. Here is the adjacent leg divided by the hypotenuse. Okay, so the length of the adjacent leg divided by the hypotenuse. Again, for theta, what's the leg adjacent to that? Well, adjacent just means next to. Some students might say that C is next to theta, and you're right. C, okay, this is adjacent to that angle. However, it's the adjacent leg. C is not a leg, it's a hypotenuse because it's opposite that right angle there. Okay, B is the adjacent leg. And then the hypotenuse is C again, right? Because it's just, the opposite of the right angle. Okay? And then tangent is the opposite leg, which we already said was A, and the adjacent leg, which we already said was B. Okay, and so there's our ratios. Now, normally there's numbers that we get, but because we just did this generic kind of triangle, that's what we end up with right there. All right, the way we remember these ratios, right, because it's a lot to keep in mind, all these different, relationships with their angle names and stuff like that. So sine is opposite over hypotenuse, sine opposite over hypotenuse. Cosine is adjacent over hypotenuse, cosine is adjacent over hypotenuse. Okay, and then finally tangent is opposite over adjacent, so T-O-A, and SOHCAHTOA is the name we used. Help us remember those trig ratios, okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent, T-O-A. All right, another thing that we talked about in geometry class was we studied two special right triangles, okay, and those two special right triangles are the 45-45-90 and the 30-60-90, okay, and they have these special relationships. And again, I'm using like generic side lengths here, okay, so but that's what we're gonna put these together then, and we're going to look at evaluating sine, cosine, and tangent for some specific values of sine, cosine, and tangent, okay. Specifically, we're going to look at evaluating sine, cosine, and tangent for these special right triangles. And we're going to be able to do it in such a way that we don't need a graphing calculator or a calculator to evaluate trig functions. Okay, so this is going to take at least 2 days to do, but it probably will end up being, 3 days. We'll see. But we're going to spend a little time here, okay, because this is super important and a little tricky to get down to. So let's talk about trigonometry, sine, cosine, and tangent, and the special right triangles on a unit circle. So for a unit circle, what makes it a unit circle? Well, it's a circle, obviously, right? You can see our circle right over here. It's centered at the origin, and the unit part is because it has a radius of 1, right? A unit normally refers to 1, okay? We're going to look at evaluating sine, cosine, and tangent for some specific angles that I selected here, okay? And you'll see kind of how they're all related, or why they're, how they're related here in just a second. So let's first of all focus on finding 30 degrees. And so we want to find sine of 30 degrees, cosine of 30 degrees, and tangent of 30 degrees. Awesome. Okay, yeah. So I already drew a 30, 60, 90 right triangle here in my unit circle. And so how's that going to help us? Well, remember that the angle of rotation here, if this is a 30-degree angle, that means from this initial side right here up to this terminal side, right, that's a 30-degree angle. And so this is, right here, that's our 30-degree angle, which I don't really need to label because it's already there for my right triangle, right? And so if we use our information here, let's think about this first. So let's try and, to find sine, cosine, and tangent, we need to find some of these side lengths of this triangle. What do we know? Well, the unit circle has a radius of 1, right? Well, there's the center of my circle, and there's a segment that goes to the end, or this edge of my circle. So what's that length have to be? Well, 1, right? So the hypotenuse of my circle is 1. Sorry, the hypotenuse of my triangle is 1. The radius of my circle is 1, so the hypotenuse of my triangle is 1 there, because of the way it's drawn, right? Then, if we go back up here to our relationships, right, that 1 is in the position of the 2 times a. So that means this a right here, that's opposite the 30-degree angle, it's going to be half the hypotenuse, right? If the hypotenuse is twice a, then this will be half of that. So, if the hypotenuse is 1, half of 1 is 1/2, right? And our third side here, our other leg, a times the square root of 3. Well, if we know a is 1/2, then a root 3 will be 1/2 times root 3. But we normally write that as root 3 over 2. And voila, there's our information. So now I can do the sine of that, okay? So let's see here, the sine of 30 degrees, because again we're going to use a 30-degree angle here, the sine of 30 degrees is going to be opposite leg over hypotenuse, so 1/2 over 1, which is just 1/2. Okay, the cosine of our angle theta there is going to be adjacent leg over hypotenuse, so root 3 over 2. And then the tangent will be opposite leg over adjacent leg, so 1/2 divided by root 3 over 2. Remember that in situations like this, right, we can, from our rational functions, you can change that to multiplication by the reciprocal. The 2's will cancel. We'll have, 2's will cancel. We'll have 1 over root 3, which you can write that there. But more likely, you're going to see a rationalized version where we take this 1 over root 3 here, and we multiply the bottom by a root 3 to create a perfect square, so it'll simplify nicely. And then, of course, by root 3 in the numerator too, because that's just multiplying by 1. And so we get root 3 over root 9, which is just root 3 over 3, like that. And this is the more typical way you'll see that, so I would suggest, remembering that one right there. Okay, so now, what about these other angles, right? These other angles that we've got up here, what can we do? Well, let's do that. So 150 degrees, let's see. So if this is 180 right here, then 150 will be like, something like that. Okay? Now if you compare this side right here and this side right here, it looks like a reflection over the y-axis, and in fact it is. Okay? So in other words, the hypotenuse here is going to be 1, right? So I could also then, reflect this side over the y-axis right to here, and then this side will also reflect right to here as well. Oops. Okay, so in other words, this angle right here is a 30-degree angle. So this 150-degree angle, although it looks, completely different, it ends up creating another 30-degree angle off that x-axis in the opposite direction, right, from what we're used to seeing. This angle right here is known as a reference angle, okay? It's like how close your angle is to the x-axis. So this 150-degree angle has a reference angle of 30 degrees. Okay, so keep that in mind. That's the reference angle there for the 150. Okay, so what comes along with this? Well, we still have a 1/2 here. This distance, okay, is still a distance of root 3 over 2, but because we're going to the left of our x, or to the left of the origin, right, we're going to treat this like a negative root 3 over 2 because it's like a coordinate, okay, in this case. So then what is the sine going to be? Well, sine is going to be opposite over hypotenuse. So 1/2 over 1, which is just 1/2. Okay? And then for cosine of 150 degrees, cosine is the adjacent leg over the hypotenuse. So it's going to be negative root 3 over 2. Like that. Okay? And then tangent is going to be the opposite leg, 1/2 over the adjacent leg, negative root 3 over 2, which is the exact same ratio we did before. And so we're going to end up, but it's going to be negative, so it'll be negative 1 over root 3 or negative root 3 over 3. Again, either one of these answers is fine. You don't have to write both. Okay? I should run a little on time here. This one might be a little bit longer, but hopefully it'll get better as we go. I won't have to do the next, so it'll be also a shorter homework assignment too. Okay? So anyway, all right, next angle we've got is the 210 degrees. So let's see here. That was the 150. Get rid of all this here. Whoops. Got rid of too much. Let's see. Can I get rid of just there? Okay. This is what you all paid to see, right? It's just me messing up, trying to erase things. Okay. So 210 degrees. So again, if this is 180, then 210 will go around past that 180. And 210 is, guess what? 30 degrees more than 180. Okay? So it again creates another 30, 60, 90 right triangle here. Okay? Where there's our right angle. Okay? This will still be a 1 because it's the radius of our unit circle, right? This will be a negative root 3 over 2. Okay? Because again, we're going to the left. And then this will no longer be positive 1/2, it'll be negative 1/2. Okay? And so again, we can put our little theta in there and imagine finding sine. Sine is going to be the opposite leg over the hypotenuse. So negative 1/2. Cosine will be adjacent leg over the hypotenuse. So negative root 3 over 2. And then tangent will be the opposite leg over the adjacent leg. Now, since they're both negative, we're going to end up with a positive 1 over root 3 or positive root 3 over 3, whichever one you like there. Okay? And then finally, the last one here, 330 degrees. Well, you might have figured out what's going to end up happening here. We will create another. So 330, well, here's, if we go all the way around, that's 360, right? So if we go 30 degrees back, okay, sorry, my triangles, because my circle's ugly. They should look like a reflection of each other, but I didn't draw my circle very well. Hypotenuse is 1. Okay, so again, this around to here is 330 degrees, meaning this little angle right here is another 30-degree reference angle. Okay, again, the distance from your angle's terminal side to the x-axis, that 30-degree reference angle is what we've got there. And that makes this 60. And so that makes this 1/2, but it's going to be a negative 1/2 though because it's going down, right? And then this length right here is still positive root 3 over 2 because, we're going to the right there. All right, now we can evaluate sine of these. So again, sine of 330. We'll use this angle, okay, because that's, the reference angle that 330-degree angle, the reference angle to that 330-degree angle. So sine is opposite 1/2 over hypotenuse of 1, or negative 1/2 over 1, so negative 1/2, okay. Cosine is adjacent root 3 over 2 over 1. Okay, positive root 3 over 2. I should make sure that looks positive. There we go. And then finally, tangent is the opposite over the adjacent leg. So negative 1/2 over root 3 over 2. So it's going to be another negative 1 over root 3 or negative root 3 over 3. Okay? So what do we see here? Well, for all these angles that all have a reference angle of 30 degrees, okay, so remember again, our 150 degree angle that went around this way, okay, it was 30 degrees away from the x-axis, right? Our 210 degree angle, okay, it also was 30 degrees off the x-axis, and this way, right? And then this way. And then this 330 degree angle, 330 degree angle, right? It was also 30 degrees off the x-axis, but in the back and back there, okay? So we have, 4 angles that we all have a reference angle of 30 degrees. They're all 30 degrees away from the x-axis. And so they all create these special right triangles, and they all result in the same signs, except they're, the same sign, right? Except there's, they're either positive or negative, right? Cosine are all the same numbers, except they're either positive or negative. And then tangents are all the same, but they're either positive or negative. So that's what we're going to be using to help us evaluate these, okay? We'll be able to use our special right triangle here. Once you see that 30 degrees, and if you want to, once you figure out that reference angle, you can use your special right triangle to help you evaluate it. So let me show you what I'm talking about here. Okay, so reference angle, just real quick. Is the difference, the angle's distance to x-axis, okay? Angle's distance to x-axis. So let's talk about this here. So let's evaluate sine of 30 degrees. All right, so sine of 30 degrees. I'll bring out my reference triangle here to help us. I'll put the 30 there, the 60 here. So that's 1/2, that's 1, and that's root 3 over 2. So sine of 30. Ugh. Okay, so opposite over hypotenuse, 1/2 over 1. If you type sine of 30 degrees in your calculator, you're going to get 1/2 over 1, or just 1/2. As long as your calculator is set to degree mode and not radian mode. Okay, if your calculator, if you type in sine of 1/2 and you get something else besides, type in sine of 30 degrees and you don't get a 1/2, press the mode button on your calculator and make sure you change it to DEG and not RAD. Okay, we're going to focus on just degrees today. Okay, cosine of 210 degrees. Well, 210, it's not clear that's a 30 degree angle. However, if we draw a little, coordinate plane here, and I rotate around, there's 180. Right? If I go a little bit further, I'll be at 210. But 210 is 30 degrees away from 180. So we can treat this 210 like it's a 30 degree angle. Okay, so 30 degrees, cosine, so we'll treat it like a 30 degree angle. Okay, so cosine of 30 degrees is adjacent, root 3 over 2 over hypotenuse 1. Okay, now the one thing we got to watch out for though is the sign, whether the answer is positive or negative. Remember that in quadrant 3, which is where we are, cosine was negative root 3 over 2 in quadrant 3. So this answer's got to be a negative root 3 over 2. Okay, tangent of 330 degrees. Okay, well, again, let's think about where 330 degrees is and what its reference angle is. So let's see here. There's 90, 180, 270. This to here would be 360. So we need to go back 30 degrees, and there's our 330 degree angle. So in other words, this has a reference angle of also 30 degrees. Spoiler alert, all of these have reference angles of 30 degrees today, since we talked about that. Tomorrow we'll talk about reference angles of 45 and 60 degrees, okay? Probably just 45 because of timing, because I'm already going really late here. But again, I promise the homework will be short. Okay, so tangent of 30 degrees. Tangent is opposite over adjacent, sorry. So 1/2 over root 3 over 2, which again simplifies to that 1 over root 3 or the root 3 over 3. Tangent, though, we're in the fourth quadrant, remember, with that 330 degrees. That's the actual angle we're trying to do. So tangent for 330, it's going to be negative, right? There's actually an easy way for you to remember, another like little memory device to help you remember where this sine, cosine, and tangent are positive or negative. All trig functions are positive here. Sine is positive here. Cosine is positive here, and then tangent is positive here. Okay, and then everything else would be negative. So in quadrant 1, all the trig functions are positive. Sine is positive in quadrant 1, or quadrant 2, I should say, but not cosine or tangent. And oops, I got this mixed up. Sorry, this is tangent. Tangent's positive in quadrant 3, and then cosine is positive in quadrant 4. Okay, and so there it is. All right, we'll do these last ones here. So sine of 30 degrees, so negative 30 degrees. Okay, that's a little bit strange, but negative would just mean we were down in quadrant 4 there. So again, we'll do sine of 30. Sine is opposite over hypotenuse. So we'll get 1/2. And we're in quadrant 4 because negative 30 degrees is in quadrant 4, and so it's going to stay positive. Okay, 390 would rotate 360 and then go 30 degrees more into this quadrant, which is quadrant 1. Okay, so what's cosine of 30 degrees? Cosine is adjacent over hypotenuse, so it'll be root 3 over 2, and it's going to be positive because we're in that first quadrant. Okay, and then finally tangent of 30 degrees. Okay, tangent of 30 degrees is adjacent, nope, opposite over adjacent. Okay, TOA, it's SOHCAHTOA, TOA part. Okay, and so that's going to be again our 1 over root 3 or the root 3 over 3, which in our calculators, sorry, not in our calculators, which if we look at our where is 510 degrees? Well, let's see here. 90, 180, 270, 360. 360 plus 90 gets us to 450. 450 plus 90 gets us to 540. So 510 degrees is right in here in quadrant 3. Sorry, quadrant 2. And sine, and so only sine is positive in quadrant 2, so this tangent is going to be negative. Okay, so again, I'm going to give you guys a few problems to do. It's not out of the book. It's just going to be like just some more of this. Okay. You can use your calculator to help check you if you want to. Don't fret too much if this is like confusing because it is kind of tricky to do. I will do more practice of this tomorrow and then the day after as well. Okay. So thanks, guys.